Hello students, welcome to Educate. Today we are going to continue with the third chapter of class 12 physics, cells, EMF, internal resistance. So suppose this is a cell, so its electrolyte will offer certain resistance. Let's represent it like small r, this is called internal resistance, and then we connect it to an external resistance R, and then there is a key, and now circuit is completed. Suppose we write EMF of cell as E, so direction of current will be like this when switch is closed. So if we say that this current is I, then we can write E equal to I times total resistance small r plus capital R, or I times small r plus I times capital R. If you remember from Ohm's law, IR equal to V, so we can write it as IR plus V. Here V is called terminal voltage. Now here it is obvious that E is larger than V, right? Now suppose switch is open. This is case of closed switch. Now suppose we consider open switch. What will happen in case of open switch? Current will not flow, so it will become E equal to V. In that case, EMF of a cell will be equal to terminal voltage. So this is the case when current is drawn from the cell. Suppose cell is being charged. In that case, whether same relation will hold or not. So in that case, situation will be different because source will be connected to, here suppose there is AC source. So AC source will be connected to this terminal, but generally we use DC. So here suppose certain value of DC is being used, and positive of cell is, this is suppose source, and this is positive of cell is connected to positive plate of the source. So in that case, formula will change. Here it has internal resistance, other things remaining same. There will be external resistance R, circuit will be closed. I'm not putting the switch here. In this case, what will happen? Here relation will change. It will become, in this case you have seen E equal to IR plus V, but this time it will not be like this. It will be V equal to E plus IR. So terminal voltage will be different in that case. We will study one numerical based on it, then thing will become very clear. So what we have seen here, that I is equal to E divided by small r plus capital R. If we take one example here, suppose this is a cell whose EMF is 10 volt and its internal resistance, say it is 1 ohm, and it is connected to a resistance R which is 9 ohm, and there is a key which is closed. And if you want to find out what is current flowing through this circuit, then you can write 10 divided by total resistance 1 plus 9 equal to I, which gives I equal to 1 ampere. So you have understood. Now suppose there are many cells in series, like this is one cell, there is another cell, then next cell, then next cell. Suppose it has EMF E1, it has E2, then E3, E4, and their internal resistances are R1, R2, R3, R4. Then what is equivalent potential or equivalent EMF of the combination, and what is the total internal resistance? Suppose we want to find out. So E equivalent will be equal to E1 plus E2 plus E3 plus E4, and R equivalent internal resistance will be R1 plus R2 plus R3 plus R4. But what do you observe here? Plus minus plus minus plus minus plus minus. Suppose any one cell has a reversed polarity. Suppose we consider this situation. So this is like this, but here second one is just opposite. Then again like this, then again like this. So E1, E2, E3, E4, and internal resistances are R1, R2, R3, R4. In that case, what will happen? What will be effective resistance and what will be effective EMF? So E effective or E resultant will be, this will be positive, this will be positive, this will be positive, but this will be negative. So you can say E1 minus E2 plus E3 plus E4. And as far as internal resistance is concerned, it will remain same. Means as so R1 plus R2 plus R3 plus R4. I think you have understood. Now we can consider another situation in which there are two cells with the same polarity in one side. Suppose this is one cell E1 and its internal resistance is say R1, and then there is another cell here, this is E2, and its internal resistance say it's R2, and you connected them like this. So here what is E equivalent? In this case, E equivalent will be found by using formula E equivalent divided by R equivalent will be E1 divided by R1 plus E2 divided by R2, where R equivalent, 1 upon R equivalent will be 1 upon R1 plus 1 upon R2. And then we can find E equivalent. So let's do one numerical, then thing will become very clear. So suppose E1 is given as 10 volt, its internal resistance say R1 equal to 1 ohm, E2 is given say 5 volt and its internal resistance is also 1 ohm. Now you have to find out what is equivalent EMF and what is equivalent resistance. So equivalent resistance 1 upon R equivalent can be found 1 upon 1 plus 1 upon 1. So that will give R equivalent will be 0.5 ohm, R1 by 2. And you have to find out E equivalent. So for that you just write E equivalent divided by R equivalent, you have found as 0.5 equal to E1. E1 is 10 divided by 1 plus E2 is 5 divided by 1. So this will be 15, and then so E equivalent will be 15 multiplied by 0.5. So this will give 7.5 volt. I think you have understood. Now we are going to see next thing. Here Kirchhoff's rule. Kirchhoff's rule means we will study two rules. One is KCL, another is KVL. KCL, this is current law, and there is KVL, that is voltage law. So what is current law? First of all, you should remember that here charge is conserved. You have to keep in mind, this is an important point. Here not voltage but energy is conserved. Right? So this is basic point that you should remember. Now next point, what is KCL? Means at any junction, suppose this is junction, here there are many currents, some are incoming, some are outgoing. Suppose we take I1 as incoming, I2 as incoming, and here I3 suppose outgoing, I4 as outgoing, I5 as outgoing. So algebraic sum of all currents is 0. What does this mean? Why do we use algebraic word here? So logic is very simple. If we take incoming currents at positive, then outgoing currents will be negative. So their sum will be 0. So here you can write I1 plus I2 positive minus I1 minus, I3 minus I4 minus I5 equal to 0. What do you get from here? You can take these three two are just so I1 plus I2 sum of incoming currents equal to I3 plus I4 plus I5. So you can also say that sum of incoming currents is equal to sum of outgoing currents. So there is no accumulation of charge at any point. So this is KCL, Kirchhoff law of current, right? And we consider KVL. So this is also called loop rule. So KVL. So in this case, suppose we can understand it by some example that will be better. Here there is resistance and then there is another cell and here there is resistance, suppose. So here say this is E1, this is E2, say 5 ohm, say 6 ohm. Now imagine that E1 is greater than E2. So total current will be in this direction. So say this is I. So what you have to do, you have to consider a closed loop. Suppose you move in this direction. You are considering closed loop. Then sum of voltage equal to sum of products of IR. So let's see voltage in the direction of current. What you have to check, suppose this is cell and you are moving from this side. So you have to take the sign of this plate. So positive sign you will write. But suppose cell is like this and you are moving in this direction. So you have to take this sign. Means sign of second plate must be considered. So you are moving in this direction. So E2 will be negative. So minus E2, and you are moving in this direction. Here you are confronting with positive plate of E1. So E1 must be equal to, if you are moving in the direction of current, then IR will be positive. So here current is flowing in this direction. So you are moving in the direction of current. So I into R, I times 6 plus here also I times 5. Correct. So this is simple example. If there are many currents, in that case what would happen? So let's see another loop. So we are considering one complex loop here. Suppose there is one cell here E1, this is say R1, and suppose current is coming in this direction. Say this is I1. There is another cell, another resistance here, say this is R2, and here again there is another cell E2, and then there is another cell here with the resistance. Now suppose this is I1, this is I2, and then the two currents will flow in this, say this is I. So here I will be I1 plus I2. And here if you apply this law, what will happen? Suppose you move like this, you just put the arrow so that it may become clear. So you are moving in this direction, second plate of this cell you have to take into consideration. So E1 will be positive. But when you reach here, so you will reach to second plate of this. So it will be minus E2. And then it must be equal to, here you are moving in the direction of current. So it will be I1, R1 will be positive. But you are going against the current. Here it will become I2, R2. Suppose this is E3 and say this is R3. And if you consider this loop and your direction is like this, then what will happen? So you can take cells. So here you are jumping to negative plate. So you will write minus E3. Here you are jumping to positive plate because your motion is like this. So it will be positive. Equals. Now consider current. So current here I1 plus I2 is flowing through this I1 plus I2, and you are moving in the direction of current. So you can say R3 times I1 plus I2. And then here also you are moving in the direction of current, plus I2 into R2. So this is how we can apply KVL. So in any closed loop, total voltage is equal to sum of products of I and R in that circuit. And rule, as you have to keep in mind, that if you are reaching to second plate and sign of second plate is positive or negative, so that depends on your choice. If you are reaching here, so this is positive, so you have to take this as positive. And if you are moving in the direction of current, so IR will be positive. So I think you have understood. Now, here one example is given. So let's draw that circuit and let's analyze what can be the formula. So here there is resistance of 200, sorry, not 200, it is 30 ohm. So resistance is 30 ohm here, and then current I1 is moving upward. Here there is current I1, and then there is another resistance 40 ohm, and here then 1 ohm, and then there is a cell whose polarity is like this is, and then it is connected here. Then after that there is another cell here, and polarity is like this is 80 volt, and there are two resistances, one is 1 ohm and another is 20 ohm. So 1 ohm or and 20 ohm. So either let's analyze from there, so it will be clear. Here clear picture is there, so it is better. Now here we can take the loops, so it will be clear. If you consider this loop, if you move like this, suppose your motion is like this, like this, like this, and like this. So first let's consider the EMF. So according to your motion, you are reaching at positive plate of the cell, so you will write 45 here equals this 1 ohm, 40 ohm, so 41 ohm, it is in the direction of current, so 41 into I3, correct. And if you move like this, here again 30 into I1, you are in the direction of current, so 30 I1. This is equation number 1. Now if you consider this loop and you move like this, keep in mind, choice is yours. It is not necessary that you should move like this. You can change the direction also. So suppose we are moving like this, so the cell will be positive, so we will write here 80 equals, then this is 1 ohm, this is 20 ohm, so 21 ohm, and you are in the direction of current, so 21 I2, sorry, 20 plus 1, and then I2. Then what is happening here? You are getting positive plate again, so positive plate sorry, so positive, so 45 will be positive here again. Then you are again moving in the direction of current, so this is 41 and I3. So this is another equation, and if you consider this point, here I3 current and here I1 current is moving in this direction, here it is coming. So what is here incoming current? Incoming current is only I3, and I1 and I2 are outgoing current. So you can say I3 must be equal to I1 plus I2. So this is another equation. So we have 3 equations, and how many variables are there? I1, I2, I3. 3 variables are there. So we can easily find the value. I think you have understood. Now, let's consider this question. This question says, in this question, there is a structure in which 12 sides are there, and each side has resistance as 1 ohm, and it is connected through 10 volt battery, and the points are diagonally opposite. So we assume that 3I current enters at this point. The logic is simple because there are 3 branches of equal resistances. So current will be equally divided. So that is why we have taken 3I. So when 3I current enters at this point, then what happens? I current will be divided in this, I will go in this, I will go in this. At this point, again, there are 2 branches of equal resistances. So I by 2 and I by 2 will go like this and like this. Now let's consider this. At this point, again, same thing is happening. I by 2 will be in this direction, I by 2 will be in this direction. Now reach at this point. From this direction, I by 2 is coming. From this direction, I by 2 is coming. So this will be sum of I by 2 and I by 2. So I current will go to this point. Now, reaching at this point, what is happening? If you consider this current is I, at this point it is divided into 2 parts, I by 2 and I by 2. And from here I by 2 is coming. So in this branch again we will get I. The same is happening here. At this point I by 2 current is moving from here and I by 2 is coming from here. So the 2 will combine and they form I. So at this terminal again you will see that 3I current is reaching and then that is flowing like this. So circuit is analyzed. Now our question is, what is the value of I and what is the equivalent resistance of this figure? So very simple thing. What we can do, let's take the equivalent resistance of this all as capital R and we assume that 3I current is entering in it through this battery is 10 volt. So we write the equation 10 volt, not volt, just write 10. 10 equal to 3I times R. Let's write is R equivalent. I'll leave it here. And now consider any closed loop. Suppose we consider this loop, this lower one, like this till here. So 10 volt battery is here. Then here current is I and the resistance is 1. So we will get 1I. So let's write I. Then through this branch, current resistance is 1 and the current is I by 2. So we will get I by 2. And then through this branch, you are reaching here. We are considering this loop. Sorry. So this will become I. Now, what are you getting from here? This will become 5I by 2 equal to 10. So 20. So I equal to 4 ampere. You have got the value of I. And if you put that value over here, you will get R equivalent. So R equivalent will be equal to 10 upon 3 into 4. So that is 5 by 6 ohm. I think thing is very clear. Now let's analyze this circuit again, and we will write the equations and then we can solve those equations because they will involve 3 variables, but I think you can easily do 3 variable equation. So if you consider the loop A, B, C, A, B, C, A, what do you get? If you move in this direction, so you can say I2 into 4, then here 2 into I2 plus I3, you are coming like this, plus 2 into I2 plus I3. Then you are moving in this direction, so 1 I1. So just write I1 equal to. Here you are reaching to positive plate of the cell. So you can write 10, this equation number 1. So we have considered this loop. There is no problem. Now suppose we consider this loop and we again move in this direction like this. Then what will happen? Again we can start with the 10. 10 equal to. Here I1 minus I2 times 4. I1 minus I2 times 4. Then you are moving like this and current is coming just opposite. So you have to write minus twice of this I2 plus I3 minus I1. And then you are moving in the direction of current. So that is okay. So here this is I1. So this is another equation. Similarly, If you consider this loop, third loop, you can move like this. Here there is no resistance, so you don't have to multiply. Here there is no resistance, so you don't have to multiply. Just write 5 equal to, because you are reaching to positive plate of the cell. So here twice of I2 plus I3, and then here what is current? Current is and you are moving in the direction of current, so you will write I2 plus I3 minus I1 times 2. This is another equation. Now you can solve to get I1, I2 and I3. Now we are going to consider Wheatstone bridge. So what is that, and what is its condition when it is balanced? So that we are going to derive. So situation is simple. Again, we will apply KVL and we will write the relations, and then we will say that when bridge is balanced means what? These are 4 resistances connected through a battery, and this is galvanometer. When we say that bridge is balanced, it means through galvanometer we will consider its resistance as G itself, and we will write the current as Ig in this branch, and we say that the bridge is balanced and there is no current here, Ig. In that case, we will try to find out the ratio of these two resistances, or ratio of these two and these two. So that is the only purpose, and it will help us in solving some resistances. Like suppose we are given resistances like this. Suppose this is 5 ohm and say this is 10 ohm. Say here this is 4 ohm and say here this is 8 ohm, and here say 15 ohm. And suppose we want to find out what is equivalent resistance between these 2 points. So it will be very difficult unless it is balanced. So here if you find the ratio of 5 upon 10, 5 upon 10 is 4 upon 8. Ratio is 1 upon 2. It means bridge is balanced, so you can remove this portion. So you will be left with here, this is 5 ohm, then 10 ohm, and here you will get 4 ohm and here 8 ohm. And now easily you can evaluate the equivalent resistance. These two are in series, these two are in series. First you will evaluate, and after that you will say that these two are in parallel and equivalent resistance can be found. So for that purpose we study this Wheatstone bridge. So now we are going to analyze what is happening here. So if we consider this loop number 1, and we move like this, so we can say I2 times this resistance is R2, so I2 times R2, right? And here we are moving like this, so plus I1 times G, and here we are going against, so minus I1 times, here not I, here Ig current you have to write, right? So let's write it separately so that thing may become clearer. So I am drawing the diagram here. So for you it will be convenient. Suppose one resistance is here, another resistance is here, third resistance is here, fourth resistance is here, right? And here there is galvanometer. It is connected through a cell, and say let's write it as P, this Q, this is R, and this S, and here this galvanometer high resistance G. We say this current is I1, this is say I2, and here say this is Ig. So since I1 is divided into two parts, so I1 minus Ig will flow through this, and here Ig is meeting at this point to I2, so here in this branch I2 plus Ig will be the case. Now if we consider first loop, what do we get? If we move like this, so we can write I1P and plus Ig into G, and then minus I to R equal to 0. This is first equation. Later on, we will apply the concept that Ig equal to 0. When Ig equal to 0, then this term will vanish and we will get I1P equal to I to R. So we take this as equation number 1. Similarly, we consider this loop and suppose we move in this direction. So we can say I1 minus Ig times Q is not equal to, just write Q and then you move like this, minus I2 plus Ig times S minus Ig times G must be equal to 0 because there is no cell here. Again, same condition we apply. We write that Ig equal to 0. So this term will vanish, this term will vanish, and this term will vanish. So we will be left with I1Q minus I2S equal to 0 or I1Q equal to I2S. Then we divide these two equations. Equation 2 and this was equation 1. If you divide, you will get P upon Q equal to R upon S. So this is condition for wheat-stone bridge to be balanced. So condition you have understood fully. Now very simple thing, if any one resistance is unknown, other three are known, then we can use this relation and thereby we can get the answer. So you have understood. Here there is one numerical based on that, but bridge is not balanced because it is showing some current. Then you have to take even cell into consideration and then you will write some relations and after that you can solve it. So let's analyze it. So if you consider this loop number 1 and you move like this, so what happens? I1 into 100, then Ig into 15, then you are going against I2 into 60 minus I2 into 60 equal to 0. This will be first equation. Then if you consider this loop, so in this case suppose you are moving like this, so your equation will be I1 minus Ig times 10 minus you are going against, so I2 plus Ig, I2 plus Ig multiplied by 5 and then again minus Ig into 15 minus Ig into 15 equal to 0. So this is second loop. Now consider this loop, outside loop, in which battery is also there and move like this. So your equation will be 10 equals from here, this is 60 I2, so 60 I2 plus you are moving like this, I2 plus Ig, I2 plus Ig times 5. So these are three equations, this equation number 1, 3 and then we can solve to get the answer. So solution I am not doing, solution is given and you know how to solve. Here after solving the questions, solving the equations, answers are given like here I1, I2. So we can get the values like I2 is 31.5 times Ig and after that when we get Ig then other values can be found. So this is how lesson is over. Thank you for watching. Team Educate.